injections are two techniques employed to introduce chemicals directly into the xylem of trees. Implants, such as capsules and some micro-injections, rely on the transpirational stream to move materials systemically within the xylem. Some injection techniques involve supplemental pressure to reduce injection time. Implants and injections have been used successfully to introduce essential elements into trees to treat micronutrient deficiencies, but they are not practical for supplementing macronutrients because of the volume required. As with foliar sprays, these techniques are most successfully used to correct minor element deficiencies. Implant or injection treatments should never be used on drought-stressed trees because uptake and distribution is best achieved when the tree is actively transpiring. To minimize injection wounding, small, clean holes should be drilled close to the base of the tree at the root flare. Insertions should be made soon after drilling to reduce chances of a blockage inhibiting uptake. Implants or injections should be placed below the bark and cambium directly into the first rings of the xylem. Injecting directly above or below other wounds may cause severe injury, thus injection wounds from previous applications should not be reused. Trees less than 4 inches, 10 centimeters, in diameter should not be treated with implants or injections. Many experts are hesitant to recommend implants or injections because of possible damage to the cambium or xylem. Although treatments using systemic injections may yield remarkable results, repeated use can cause wounds to fuse. Therefore, implant or injection treatments should not be made less than 1 year apart. A minimum of 2 years is preferred. These techniques can be a temporary treatment, but they are not recommended for routine use. They should be applied only when soil application techniques are impractical or ineffective. The photo illustrates discoloration of the xylem caused by an injection treatment. Some organic mulches can improve plant health and growth and may decrease the need for fertilization. As organic mulch decomposes, it can release essential elements into the soil. Long-term benefits provided by organic mulches include improvement of soil structure, permeability, aeration, fertility, and biological activity. Some organic mulches can improve plant health and growth and may decrease the need for fertilization. As organic mulch decomposes, it can release essential elements into the soil. Long-term benefits provided by organic mulches include improvement of soil structure, permeability, aeration, fertility, and biological activity. Some organic mulches can improve plant health and growth and may decrease the need for fertilization. As organic mulch decomposes, it can release essential elements into the soil. Long-term benefits provided by organic mulches include improvement of soil structure, permeability, aeration, fertility, and biological activity. A number of products are available and marketed as soil additives. Soil additives range from various forms of organic matter to vitamins, mineral elements, and seaweed. Some additives have the potential to improve soil biology and structure, providing indirect benefits for the health of the tree. Unfortunately, little research is available on the efficacy of some of these products, and in some cases, there is limited evidence of their value. One popular group of additives is soil inoculants. Recognizing the important role of mycorrhizae in water and mineral absorption, researchers have sought to encourage mycorrhizal development in tree roots. It should be clarified, however, that mycorrhizae are the result of a symbiotic relationship between tree roots and specific fungi. Mycorrhizae cannot be added to the soil, but the soil can be inoculated with spores of mycorrhizal fungi. The goal is to introduce the fungal inoculants, which might in turn form mycorrhizae. Mycorrhizae are influenced by soil pH, light, minerals in the soil and plant, and other competing mycorrhizae in soil microbes. Therefore, inoculation should be adapted to match the plant species and site as much as possible. While inoculation has been very successful in poor soils where fertility and microbe populations are low or non-existent, fewer benefits have been shown on more favorable soils. Recommended fertilizer rates are based on achieving a good tree response while avoiding fertilizer burn. Fertilizers, especially inorganics, are actually salts of different chemicals that are essential for plant growth and health. Fertilizer burn is the same type of injury that can be caused by common salt, sodium chloride, used for de-icing. Excessive salinity in the root zone can actually draw moisture out of the roots. Symptoms range from wilting and marginal burning of the foliage to death of the plant. Some fertilizer labels specify the salt index, which is a relative scale, compared with sodium nitrate, that indicates the likelihood to cause burning. A fertilizer with a salt index below 50 is usually preferred. The use of slow-release fertilizers can minimize salt injury. Under normal conditions, i.e., without drought or flooding, water held within the soil pore space is readily accessible to plant roots. Although plant tissues may contain more than 80% water, their roots are able to maintain a lower water potential than the surrounding soil by accumulating solutes, salts, within their cells. If fertilizer is applied excessively or without proper irrigation, the concentration of salts within the surrounding soil may be much greater than the concentration of solutes, salts, found in the root cells. This leads to a phenomenon known as reverse osmosis, in which water is drawn out of the roots. If steps are not taken to correct these conditions, the plant will experience root burn. Under normal conditions, i.e., without drought or flooding, water held within the soil pore space is readily accessible to plant roots. Although plant tissues may contain more than 80% water, their roots are able to maintain a lower water potential than the surrounding soil by accumulating solutes, salts, within their cells. If fertilizer is applied excessively or without proper irrigation, the concentration of salts within the surrounding soil may be much greater than the concentration of solutes, salts, found in the root cells. This leads to a phenomenon known as reverse osmosis, in which water is drawn out of the roots. If steps are not taken to correct these conditions, the plant will experience root burn. Leaching is the washing of chemicals down through the soil. Normally, nitrogen and other water-soluble elements are continually being leached from the root zone. Not only does this make nutrients unavailable to the tree, but they can also pollute groundwater, lakes, and streams. To minimize leaching, apply only the amount of fertilizer needed, use organic or slow-release forms, and avoid over-irrigating sandy soils. Another factor that may limit uptake of certain elements is pH. Soil pH can influence solubility of certain elements by causing them to form insoluble salts. For example, if the soil is too alkaline, iron solubility is reduced and iron is unavailable to the tree. Thus, adding iron to the fertilizer will provide only temporary relief because the added iron will soon become unavailable. Therefore, it is advisable to perform foliar and soil analyses before treatment. The most accurate way to determine the nutrient needs of a tree is to obtain laboratory analyses of the soil and leaves. Therefore, two analyses should be considered: soil analysis and foliar analysis. A soil analysis can give information about the presence of essential elements, soil pH, organic matter, and cation exchange capacity, CEC. The pH and salt content, especially in arid regions, are crucial for recommending fertilizer treatments. A texture analysis that determines the amount of sand, silt, and clay present in the soil is also important to assess the physical characteristics of the soil. When sampling the soil around the tree, small cores should be taken from representative locations of the entire area or root zone and then mixed together. The goal of this procedure is to avoid pockets where levels may vary. Any soil test is only as good as the sample. Therefore, it is important to collect a representative sample of the site. Click on the play button to see a demonstration on how to use a soil probe to take a soil sample. Because tree roots grow over a vast area and at various depths, soil analysis alone may not yield accurate results for certain soil elements. Also, there is still debate about which levels of various elements are critical for tree growth, and required levels vary by tree species. Leaf samples for a foliar analysis should be taken from all over the tree and then dried and analyzed to help diagnose certain deficiencies or toxicities. Interpretation of foliar analysis results should account for seasonal and species fluctuations in foliar nutrient content. Comparing foliar analysis results of both healthy and symptomatic trees of the same species may facilitate result interpretation. A soil analysis or foliar analysis alone can be misleading, though. Certain nutrients might be plentiful in the soil but unavailable for plant uptake due to the soil pH and other factors. Although some fertilization can increase growth, it is not always beneficial. Excess fertilization can injure trees and reduce tolerance to certain stress and/or pest problems. Studies now show that nitrogen fertilization can trigger a tree's energy allocation toward growth, sometimes at the expense of defense. Even though fertilization is often recommended to help give ailing trees a boost, trees stressed by drought, poor soil aeration, and some diseases may not respond to fertilization. Nutrient management should consider soil structure and biology, not just soil chemistry. Fertilization is just one plant health care treatment available to arborists. Current practices are moving toward what is known as prescription fertilization based on element analysis. This is an apt term, keeping in mind the medical saying, prescription without diagnosis is malpractice.